Today you'll be learning to determine molecular formulas. So our objectives is that if you are given an empirical formula, remember that means a reduced formula, and the molar mass, find the molecular formula. And second, if you are given the percent composition and the molar mass, find the empirical formula, and then you can find the molecular formula. Make sure you have a periodic table and a calculator before beginning. So when we solve for molecular formulas, what we do is if we're given the molar mass, we divide by what I'm going to call the empirical mass. So I have a table here that we're going to fill out just to give you an idea of how things are organized. So our empirical formula is CH2. We can figure out what the empirical mass would be by taking the individual masses. So that would be 12.01 plus 2 times 1.008 for the mass of hydrogen. And we get a mass of 14.03 if we round to the 100th place. Now, we've got an empirical formula of CH2. Now I want you to look over at the molecular formula column. We have C2H4. That means that we've got 2 of these CH4 units, or 2 of the CH2 units. So we have 2 CH2 units. Notice that our molar mass is twice 14.03. Now let's say instead we have C3H6. That means we have 3 of the CH2 units. So what we could do is we could take 3 times 14.03, and that's going to be equal to 42.09. Our next one is C5H10. So that means that we're going to multiply by 5. So we're going to say 5 times 14.03. And now we have a value of 70.13. Now we're going to go the other way. You're told that the molar mass is 140.3. You need to figure out how many of those CH2 units will fit in. So let's just do that off to the side. We're going to have 140.3 divided by 14.03, and that's equal to 10. So what we have is C10H20. So the approach we're going to use is what we did for that last blank. We're going to be given the molar mass, and we're going to be given the empirical formula. From the empirical formula, we calculate the empirical mass. So let's work an example. A substance has an empirical formula of CH and a molar mass of 52 grams per mole. What is the molecular formula? So what we're going to do is we're going to take the molar mass and we are going to divide it by the empirical mass. So let's do that. We have 52 right there. And then we're going to divide it by the mass of CH. And the mass of CH is 12.01 plus 1.008. And so that would be 13.018. And when we do that, we get 3.99, which really is 4, okay? So this means that we have 4 CH units. In other words, we have C4H4. So let's go back and look at what we did. We figured out the mass of the CH. That was 13.018. We took the molar mass, 52, divided it by 13.018 to give us 4. Now we know we have 4 CH units. All right, you're going to do the next one. A substance has an empirical formula of CH2O and a molar mass of 180.2 grams per mole. What is the molecular formula? I want you to pause and work the problem. Here is the worked solution. First, we calculated the mass of CH2O, the empirical mass, and we got an answer of 30.03 grams. Then we took the molar mass of 180.2 and divided it by the empirical mass and got 6. That means we have 6 CH2O units. So our final answer was C6H12O6. Now we are going to start with percent of each element. This is like what we did yesterday. We're going to find the empirical formula, and then we find the molecular formula. So this is a repeat of what we did yesterday. So these are in percents, so we can turn all of our percents into grams. So we have 40.0 grams of carbon, and we're going to convert that into moles of carbon. So 12.01 grams of carbon, 1 mole of carbon. So we have 3.33 moles of carbon. We're going to do the same thing with the hydrogen. So we have 6.7 grams of hydrogen. And we're going to do the dimensional analysis to cancel out units. And when we do that, we get 6.65 moles of hydrogen. Notice I have not rounded that hydrogen because we don't want to lose precision by rounding. And then our last one is 53.3 grams of oxygen. We're not going to make it a diatomic because it's part of a molecule. So 16.00 grams of oxygen is the same thing as 1 mole of oxygen. And we get 3.33 moles of oxygen. All right, we take this whole thing just like we did yesterday. We have C 3.33, H 6.65, O 3.33. Those are silly subscripts. So we're going to divide through by the smallest value, which is 3.33. And so we end up with CH2O. Now remember, this is our empirical formula. So we've done the first part of the problem. Now, what is the molecular formula? So we're going to have to figure out the mass of CH2O. So CH2O is equal to 12.01 plus 2 times 1.008 plus 16, which is about 30.03 grams. All right. We are told that the molar mass is 60 grams per mole. So we're going to take the molar mass and we're going to divide it by 30.03. Okay, so let's do that right under, we're going to come all the way over here. So our molar mass is 60.0 divided by 30.03. That is really, really close to 2, which means we have 2 CH2O units. So we would write this as C2H4O2. So let's review what we did again. We took our percents and turned them into grams, and we found we had 3.33 moles of carbon, 6.65 moles of hydrogen, 3.33 moles of oxygen. We took that and found the empirical formula of CH2O. We went back to the 60 grams, that's the molar mass, divided it by 30.03 to get 2. That means we have 2 CH2O units, so we multiply everything through by 2. This next one you are going to do, but I'm going to help you get started. A compound of B and H is 81.1% boron with a molar mass of 53.3 grams per mole. We're going to need that. Let's go ahead and circle it. What is its molecular formula? So you look at that and all you have is 81.1% boron. You're not given the percent of hydrogen. However, if you know that percent B plus percent H must add to 100%, then you know that if you take 100% minus 81.1%, that is going to be equal to 18.9% hydrogen. So you are given it indirectly, so watch out for that. So now you have your grams of hydrogen, you have your grams of boron. Let me warn you here, this might be one that shows up with a fraction. So I want you to pause. So let me go ahead and write that down. Pause and solve for the empirical formula. Okay, so you're going to solve for the empirical formula, and then we'll come back and do the second part, solving for the molecular part. Let's see if you got to the empirical formula. So you took the 81.1 grams of boron, and you should have figured out that that gave you 7.50 moles of boron. The 18.9 grams of hydrogen gave you 18.75 moles of hydrogen. Then you figured out the empirical formula was B1H2.5, but at this point you should have been thinking, ooh, I need to have a whole number. What can I multiply through by? And so the first thing you try is 2, and oh look, it's B2H5. Hallelujah. However, you are not done. This is your empirical formula. We want to know the molecular formula. So you've gotten this far, or you're going to fix it if you didn't get this far. I want you to pause again, and you're going to solve the molecular formula. All right, let's take a look at the molecular formula work. Hopefully you did this right. So we took the empirical formula, B2H5, and we figured out that its mass was 26.66 grams. Let me go ahead and put grams in there. We divided 53.3 grams by 26.66 grams and got 1.999, which we're going to say is 2. So we had 2 B2H5 units, which means our molecular formula was B4H10. All right, so now you're ready to do some practice on your own.